Top 10 gemstones that bend light like no other. Some gemstones don't simply shine, they distort light, fracture it, and hide entire spectrums within their core. To the untrained eye, they're beautiful. To physics, they're defiant. Inside these crystals, light behaves in ways it shouldn't. Some stones glow from within without any light source. Others split a single beam into 1,000 colors or shift their identity entirely depending on the hour, the angle, or the eyes that witness them. These aren't just minerals, they're optical paradoxes. What you see is only part of what's there. Each of the 10 gemstones you're about to encounter bends light with such precision or chaos that scientists struggle to explain what the ancients already believed. These stones were never meant for ordinary vision. Forged in extreme pressure, tempered by time, and shaped by coincidence bordering on cosmic, they challenge what we think light can do. And one of them may even reveal a color your eyes were never supposed to see. Don't forget to press and hold that like button, leave a comment, and hit subscribe before we begin. Ranked 10th. Moonstone, the light beneath the surface. A gem that doesn't reflect, it glows. Ancient legends called it frozen moonlight. Modern science calls it a masterpiece of light interference. This is the story of Moonstone, the stone that breathes. It doesn't spite, it doesn't flash. Moonstone doesn't reflect light. It holds it as if some quiet glow were trapped beneath the surface. What emerges isn't brilliance, but a soft, floating shimmer, like moonlight drifting beneath still water. Scientists call this phenomenon a dulurescence, a rare optical effect almost exclusive to this gem. While other stones chase dazzle and clarity, Moonstone offers something more elusive, a sense of stillness, a presence that moves. This light is born not from flawlessness, but from imperfection. Deep inside the stone, microscopic layers of feldspar are stacked like pages in a book. When light enters, it bounces and scatters across these thin layers, interfering with itself and producing a billowing glow that seems to shift with every turn of the stone. The effect is fragile, slightly changing the angle or thickness, and the light vanishes. It's a natural illusion, more delicate than fire and mysterious than reflection. That mystery has followed Moonstone for centuries. The Romans believed it was forged from frozen moonlight. In ancient India, it was sacred, thought to carry the spirit of a divine being, visible only to the pure-hearted. Lovers saw destiny in its depths. Mystics believed it could part the veil between worlds, but behind every legend lies something even stranger: physics. Moonstone belongs to the orthoclase feldspar family, and its glow is a product of light interference, a subtle manipulation of wavelength and waveform. Where diamonds sparkle with reflected fire, Moonstone breathes with its inner glow. No two pieces are ever the same. One may whisper in soft blue hues, another pulse like lightning under glass, but they all seem to hold something eternal, like memory, time, or silence. Moonstone remains gentle, secretive, and infinitely captivating in a world obsessed with brilliance. It doesn't demand attention, it invites wonder. But what happens when light doesn't just shimmer, but splits? When does it turn into something living, watching, and waiting? Ranked 9th. Eye Chrysoberyl, the watcher in the stone. Some stones dazzle, others that glow, but only one appears to look back. Cut it the right way, and a single slit of light slides across its surface, narrow, sharp, focused. No sparkle, no scatter. Just one beam, moving like the pupil of an eye. This is Eye Chrysoberyl, a gemstone forged not to shine in all directions, but to concentrate light into a blade. The phenomenon is called chatoyancy, from the French œil de chat, or cat's eye. Under a single light source, a bright silky band splits the stone in two, following every movement like a silent sentinel. It isn't an illusion, it's structure. Inside the gem lie thousands of needle-like inclusions aligned with uncanny precision. When light strikes, it reflects in a single plane, creating a bright line that seems to hover on the surface. The darker the body color around it, the more intense the effect becomes, until it feels less like a gem and more like something awake. In ancient cultures, it was feared, revered, and carried as a talisman against the evil eye. It was treasured by warriors and merchants alike, not for beauty, but for presence. Its narrow gaze was said to repel misfortune and guard its bearer from unseen things. Some believed it could reveal lies, and others that it held the soul of a guardian spirit. But beyond the myths lies a rare feat of nature. The structure required to create perfect chatoyancy is both fragile and precise. Too few inclusions and the effect fades. Too many, and the gem turns cloudy. Only a narrow alignment window allows the light to draw its line, and only Chrysoberyl does it with clarity and strength. Even in stillness, it moves. Even in shadow, it watches. And while most gems beg for attention, cat's eye demands silence. It doesn't entertain, it observes. But if one line of light can create the illusion of a living gaze, what happens when that light scatters in every direction at once? Ranked 8th. Labradorite. The aurora trapped in stone. Color doesn't rest on its surface. It erupts from within, electric blue, fiery gold, flashes of violet, like northern lights frozen inside a crystal shell. At first glance, it appears modest, opaque, quiet, but shift it just slightly, and the transformation begins. A burst of color, metallic, vivid, unrestrained, flares across the stone's face. What was once dull becomes electric. What was hidden becomes celestial. Labradorite is a feldspar mineral discovered on the icy shores of Newfoundland's Labrador coast. One of nature's most startling illusions lies within its gray-blue frame. Labradorescence. This phenomenon occurs when light collides with microstructures inside the gem, scattering into a sudden, spectral blaze. The effect is so surprising and vivid that early Arctic travelers believed the stone held fragments of the aurora borealis. The colors in labradorite don't shimmer gently. They detonate. Blues explode into orange. Green flashes collapse into violet. The entire surface becomes a swirling electric field in some stones, unstable, shifting, and utterly unpredictable. The source of this chaos lies deep within. Layered like sediment under pressure, thin lamellar structures interfere with incoming light, refracting it into full-spectrum bursts. Each layer, each fracture, becomes a prism, and no two stones fracture the same way. Some offer a single flash. Others reveal entire universes. Some labradorites seem to flicker with solar flares, and others cradle a soft nebula of misty blues. Their fire isn't a constant flame. It's a pulse, a cosmic Morse code embedded in a crystal. Among Inuit myths, labradorite was once the sky stone, the remains of the northern lights that had fallen to earth. It was a gift from the spirits of the cold, a reminder that not all things beautiful are meant to be stable or tame. In today's world, the gem remains a favorite, not for its rarity, but for its unpredictability. Jewelers call it a rebel stone, and photographers call it a challenge. Capturing its actual color is nearly impossible because it never appears the same way twice. What labradorite reveals is not color, but collision, a brief, blazing conflict between light and matter, a frozen storm beneath the surface of something ancient. But what if light didn't just scatter in color? What if it danced like fire across a gem's core? Ranked 7th. Color change Alexandrite. The chameleon of the gem world. One gemstone. Two worlds. Under daylight, it breathes green. Under lamplight, it burns red. A shift so sudden it feels like deception made beautiful. A green glow pulses beneath the surface in natural light. Calm, serene, controlled. Under incandescent flame, it becomes entirely red, rich, and defiant, like a secret revealed after sundown. This is Alexandrite, the shapeshifter of the gem kingdom. Its transformation is not a trick of shadow, nor is it subtle. Alexandrite changes color so dramatically that 19th century gem dealers once believed they had misclassified it. One stone, two identities, no warning. Discovered in the Ural Mountains of Russia in the 1830s, Alexandrite became an overnight symbol of duality. By day it reflected the green of the imperial army, and by night the crimson of the royal standard. As legend spread, so did its price. But behind the pageantry lies an optical effect that borders on the paradoxical. The phenomenon is called color change, but its cause is particular. Alexandrite belongs to the Chrysoberyl family, but unlike its kin, it absorbs and reflects different parts of the visible spectrum depending on the light source. Daylight, rich in blue-green wavelengths, pulls emerald tones from the stone. Incandescent light, filled with red and yellow, shifts the balance entirely. The result? A gemstone that behaves as if it's aware of its environment. To one viewer, it may glow with forest green calm. To another in the same room, it may flicker red as blood. And yet, the true drama of Alexandrite lies not just in its shift, but in what that shift suggests. That perception is fluid. That beauty is unstable. That truth depends on where you stand and when you look. No two Alexandrites shift the same way. Some lean violet, others push toward brown or bronze. Even the most prized specimens, those that flick instantly from green to ruby red, carry tension within them. A reminder that color itself is a negotiation between light and the human eye. Alexandrite is an obsession for collectors, an anomaly for gemologists, and a metaphor for poets. Because sometimes the rarest thing a stone can do is change. But what if, instead of shifting between two colors, light bent, broke, and shattered into every color at once? Ranked 6th, Andalusite, the gem of multiple realities. One gem, 3 visions, a prism for the uncertain, where every angle reveals a different truth. It resists being named. From one direction, earthy olive. From another, burnt orange. Then suddenly, deep burgundy, hiding beneath the folds. Andalusite never settles. It exists in layers. What the eye captures is never the whole story. This gemstone, first unearthed in the rugged hills of Andalusia, Spain, carries within it a strange defiance. It doesn't shift between two colors like a chameleon. It doesn't flash with light. Instead, it simultaneously divides the truth, presenting 3 versions of itself. Depending on the viewing angle, 3 distinct hues emerge, all held within the same crystal body. The phenomenon is trichroism, a rare optical effect in which a single crystal absorbs and transmits light in 3 directions, each producing a different color. Unlike more theatrical effects like Opal's fire or Alexandrite's shift, Andalusite whispers its complexity. Quiet, deliberate, fragmented. Its surface tells one story, its depth is another, and between them, a third, flickering just out of reach. In ancient folklore, Andalusite was seen as the stone of conflicting paths, a guide for the indecisive, and a mirror for those who carried more than themselves. To wear it was to acknowledge duality, not as a flaw but as a fact, that no person, moment, or truth is ever singular. Scientifically, its behavior is precise. The atomic lattice twists polarized light, bending its waves along separate axes. To the trained gemologist, this reads as a textbook case. To everyone else, it feels like holding something that cannot choose who or what it wants to be. Andalusite doesn't demand attention. It asks questions. It rewards stillness, observation, angle, re-angle. Only then does its full spectrum emerge. Not in brilliance, but in perspective. Some gems shine, some glow, and some are complicated. But what if, instead of 3 muted hues, light exploded outward, split by internal fire, and returned as color in constant motion? Ranked 5th, Opal, the stone that holds fire without flame. There is no symmetry here, no pattern, no rhythm, only chaos. Beautiful, kaleidoscopic chaos. Opal does not emit color in lines or layers. It doesn't shift politely from one hue to another. It erupts. A new flare appears at every tilt and flicker of motion. Green becomes orange. Blue becomes red, and fire spills across its skin in patterns that never repeat. This is not brilliance. This is combustion. The phenomenon is called play of color, a spectacle born not from pigment, but from structure. Deep inside opal, millions of microscopic silica spheres arrange themselves like a grid. When light enters, it's scattered across this lattice, not reflected, not absorbed. Diffraction is pure and wild, a breaking apart of white light into spectral flame. Where most gems follow the rules, cut, facet, shine, opal breaks them. It refuses predictability. Some stones shimmer like oil on water, while others blaze like the sun on gasoline. A single opal might contain more color than an entire crown of jewels, and none remains. For centuries it was feared. In ancient Rome, it symbolized pure luck and misfortune in medieval Europe. Thieves once wore opals for invisibility. Royals prized them as omens of prophecy. But no story ever entirely held opal, because no two people saw the same thing. What opal offers is not a certainty, it provides a surprise. This is a gemstone that doesn't wait to be understood. It performs, it disappears, it dazzles, it vanishes. And just when the eye adjusts, it shifts again, as if reminding us that nothing luminous ever truly belongs to us. In Australia's outback, where lightning meets stone, miners call opal living color. A fire buried beneath ancient seabeds reminds us that beauty doesn't always sit quietly. It sometimes burns. But if opal sets the stage for motion and flame, what happens when fire becomes order? When light aligns, bends, and explodes through precision? Ranked fourth, Zultanite, the chameleon of the light realm. Some gems surprise, and then some transform so elegantly the change feels inevitable. Zultanite is often whispered about among connoisseurs, not for flash, but for subtle metamorphosis. Housed within a single crystal lies an entire spectrum of moments. Champagne at noon, rose gold at dusk, sage green under starlight, no flicker, no fire, just a quiet, dignified unraveling of color across time. Known scientifically as Diaspore and renamed commercially as Zultanite, this gemstone bears one of the most refined color change effects ever recorded. Its shift is gentle, often unnoticed until you catch the light just right. Then, what once felt warm turns cool. What once seemed earthy begins to blush. The effect isn't just beautiful, it's complex. Zultanite responds to the temperature and balance of light wavelengths in its environment. Under LED or candlelight, the stone leans into pink, bronze, or raspberry. Under sunlight, it returns to soft greens or honeyed yellows. Unlike Alexandrite, which snaps between hues, Zultanite blends them, like memories layered over each other. Rarely found in large, clean specimens, most Zultanites hail from the mountains of Anatolia, Turkey, where the crystals are mined with care, often by hand. Each gem carries that ancient region's soil, sun, and silence. There are no enhancements, no treatment, just light and time. In Ottoman courts, stones of this nature were believed to reflect the bearer's inner harmony, or imbalance. One color meant clarity, and another confusion. The shifts were said to reveal more than light could explain. Today, Zultanite remains elusive, not because it hides, but because it demands the viewer slow down. One must pause, observe, and engage to see its complete transformation. It doesn't dazzle on demand. It waits for the world to change around it, for the viewer to return in a different light. But what if light no longer drifted or blended? What if it fractured with mathematical violence, splitting not into one or two hues, but into a storm of rainbow fire? Rank third, Sphene, the prism of scattered fire. More than sparkle, more than color. This is light dissected, refracted, and reborn into fire that rivals even diamond. There is brilliance, then there is dispersion. Sphene, known to mineralogists as Titanite, is not a stone for the subtle or the shy. Its surfaces ignite when light enters, not from glow or reflection, but from a raw optical explosion. What emerges isn't just beauty, it's science set ablaze. Dispersion measures how far white light splits into the visible spectrum as it passes through a gem. In diamonds, this creates fire, the rainbow flickers that dance in sunlight. But in Sphene, dispersion exceeds even that. Nearly twice the refractive spread. Red, green, gold, violet, all of them surge, sometimes in parallel, layered, crashing over each other in a chromatic storm. The internal structure is to thank and to blame. Titanite's complex crystal system, bends incoming light with intense angular distortion. Where other gems polish and direct, Sphene diffracts and fractures. The result? Chaos is so colorful it becomes order. But the effect is fragile. Even slight inclusions cloud the fire, and its relative softness makes cutting a challenge. The stone must be shaped with surgical precision to unlock its complete dispersion. Few gem cutters dare attempt it. Fewer succeed. Those that do, however, create something almost alien, a gem that doesn't just display color, but projects it. A single turn under light throws sparks across walls, tables, and skin. It behaves not as a surface, but as a prism suspended in motion. For centuries, Sphene remained in the background, known to geologists and ignored by royalty. But in the age of LED and photography, it found its revenge. Cameras struggle to contain it. Viewers pause, rewind, and replay. The light it throws can't be rendered. It must be seen. In Titanite, light loses discipline. It scatters, dances, and rebels. And just as the viewer adjusts to its brilliance, a thought arrives. If a gem can split light like this, what might happen if the stone itself began to shift? Its color, structure, and very nature, in response to time, pressure, and soul. Ranked second, blue garnet, the rarest shift ever seen. One of the rarest color changes on Earth, blue to red. A transformation so complete it rewrites what garnet means. Garnet, for centuries, has been associated with fire, ruby red, glowing, predictable. But not this one. Blue garnet doesn't shimmer, it challenges. In daylight, it appears calm, stormy teal, steel blue, ocean dusk. But under incandescent light, the blue dissolves. In its place, red, deep, unmistakable, sudden. This isn't a subtle flicker. This is a transformation as if the stone were alive, responding, reacting, almost rebelling. A shift is so rare and structurally specific that it was unknown to science until the late 1990s. And even now, few have seen it with their own eyes. The effect is born from vanadium, a trace element that infiltrates the crystal lattice. It acts like a code breaker, altering how wavelengths are absorbed and released. Under cool light, shorter blue wavelengths dominate. Under a warm glow, the vanadium opens the door to red. The shift is complete, both visually and chemically. Blue garnet was first discovered in Madagascar, and even there it occurs in only trace amounts. Later sightings emerged in Turkey, the US, and Russia, but none in quantity. A collector may spend decades searching and never find one above 2 carats. Museums guard them. Dealers whisper, it is garnet but elevated. Its structure is not exotic. Its chemistry, not extreme. And yet its behavior defies category. This isn't just a gemstone, it's a phenomenon. It doesn't entertain, it eludes. To see it shift once is to question permanence. To hold it is to carry duality. Blue and red, calm and fire, day and dusk, locked in a cycle without end. It is the rarest contradiction nature allows to exist. And if a stone can become its opposite, what then can a diamond become under pressure far beyond imagination? In the first place, Tanzanite, the flame of compressed twilight, not blue, not violet, not burgundy, but something between them, something shifting, burning, and buried beneath the skin of time. There are colors the human eye recognizes, and then there are those it only remembers. Too complex to name, too brief to hold. Tanzanite lives in that in-between. From one angle, it glows a deep blue, midnight caught in motion. From another, violet floods the surface like ink spilling through water. Tilt again, and burgundy, faint but present, rises like a bruise beneath the glass. This isn't surface play. It's pleochroism in its most extreme form. 3 fully formed colors layered not on top of each other, but within. It is as if the crystal carries parallel dimensions and is compressed into a single shard of sky. Discovered in 1967 near the foothills of Mount Kilimanjaro, Tanzanite is found in only one place on Earth, one seam, one sliver of land. And even there, its formation requires geological improbability, tectonic pressure, vanadium infusion, volcanic heat, and time measured not in centuries but in silence. Most gemstones reflect their surroundings. Tanzanite creates its own. Jewelry designers call it emotional. Geologists call it rare. But to those who truly understand it, Tanzanite is an event, not an object, a stone that performs, shifts, and misleads. It may appear as sapphire to the untrained eye, but look longer, and the illusion collapses. What remains is something richer, more volatile, more honest. Even its name is young. Before 1967, it had no name at all. After its discovery, Tiffany & Co. coined Tanzanite for marketing, but the stone's essence cannot be boxed by title. It resists branding. It defies identity. To the Maasai, it is a sacred gift. To collectors, it is finite magic. To light, it is a prism with no precise geometry. Unlike Opal, which dances, or Sphene, which shatters, Tanzanite flows. It doesn't react to light. It absorbs, digests, and releases it slowly like memory rising to the surface. No camera captures it. No cut defines it. No single color can claim it. Tanzanite is the color of what comes just before the end. The last shade before dusk becomes night, before the dream becomes sleep. A fire made of forgotten hours folded into stone. And if light has a final form, this might be it. Not all gemstones shine the same. Some reflect and others glow. But these 10 bend light in ways that challenge perception. They twist it, split it, and pull fire from silence. Each one tells a story of beauty, physics, pressure, and impossible time. They are messages carved in light, reminders that what we see depends not only on what's there, but also on how and when we choose to look. If you've reached this point, you now carry something rare, knowledge and perspective. And this is only the surface. There are still other stones, other secrets, and more light waiting to be fractured. Let us know which resonates with you in the comments, and don't forget to like and subscribe to our channel for more content like this.